Okay, so this video I'm gonna talk about tutorial 6 problem, which is generate a counter. We'll show you the code, like a simple version and the complete version. Okay, there's two versions there, and you can see simulate it in software called ModelSim, and I will talk about first how you download it if you want. Okay, so far you not necessary you have this one. It's just the software I use to do simulation. Okay, so first you will go to this website. I will put this link in the description, and you want to go to 20.11. So if you go to this link, you will direct to here. Okay, and you will click this one. It's 1.2 gigabytes. It's quite big, and you will start the download, and you just install it as usual. So you don't do anything, just click yes, yes, yes. All right. Here is a detailed explanation about how to install Cortex. Cortex is the software we're going to use later to download your program, like VHDL, your code to FPGA device. Okay, we're going to use the Cortex. It's also a very, very big software you can download from this website. And this video, if you follow this video, you will find all the procedures. Again, you are not required to install that at this moment, just let you know. And other resources. So if you go to this website, I talked about this book before. All right, so this is the website, and in this one, here are some very simple introduction about VHDL and about how to do simulation in ModelSim. Sorry, not ModelSim, it's a ModelSim. And there are a lot of useful information. It's separated by topics, so you can go to the exact one you are confused or not sure about. So the process is the one I recommend you watch it if you get confused about how to use a process. So let's go back to the code. Okay, first let's do a very simple one. So the whole question is ask you to build a counter. So count from 00040 all the way up to FFF. Okay, and you can by switch a key, then you can count backwards. All right, so before we connect with the 7 segments, we just want to create the output called count output. So it's a 16 bits. All right, 4 bits drive 7 segments. So we have a 16 bits here. So the main code here is just this one. Count equals to count plus 1. All right, or count plus 1 assigned to the new count. So every rising edge, the clock have a rising edge, then we count 1, we plus 1. So we are counting how many rising edge there. Okay, so this is the simplest code we can have. So 3 parts: library and entity define all the inputs and outputs, and architecture, there's a name of architecture of this entity. Then before you begin the architecture, you can define the signal, you can define constant, you can declare components, which we're gonna do in the next step, in the next more complex example. In this example, then we start a process. There should be a sensitivity list. You can put a sensitivity list. So this process only triggered when the sensitivity listed variable changes. If there is no such brackets here, we just assume it will be triggered all the time. Okay, and we will say begin. We're gonna begin this process. Wait until rising edge clock. Okay, if the input have a rising edge, then we do count plus 1. All right, and we assign this signal to the output. All right. So I mentioned this in the tutorial. We can't just say count output. We can't just put this one down here plus 1 and assign to the output port. It will give us an error because the output cannot exist in the right hand side of this equation. Okay, this assignment. So this is the whole thing, and I ran a simulation. So basically I wrote something called a test bench. So the test bench doing nothing but create this clock, test the clock. Okay, create this clock and send out the output to the software so we can see it. And you can see as the time pass, there's 10010101 the clock, but the counting is, this bit is keep counting. Okay, this signal is keep counting. If we change it to on sign, so you can see 1 2 3 4 all the way, is keep counting. Okay, that's a very simple code. All right, so start from that, we're gonna build a more complex one. So this is according to the tutorial question. Okay, you can see that we have again 3 parts: library, entity, and architecture. So in the entity here, instead of have 16 bits number called a count output, here we have 4 7 segments, each having 7 bits, and we have up and down bits. Okay, these are inputs, 3 inputs, and 4 7 bits outputs. In the architecture part, okay, before we start the architecture, before we begin the architecture, we define a lot of stuff. We declare the components called the 7 segments. Okay, the 7 segments have the following ports: is a standard vector, input and output. Okay, and we write this code for the 7 segment here. Again, 3 section: library, entity, and architecture. So in the architecture, you can see we use case. If the input is a hex number 0, then we have this one output to the 7 segments, make the shape of 0. We talked about this several times. Okay, and then we add everything. So this piece of code can be following your main code, or is more recommend you have another file. You can add a file here to do that, but you don't need to worry too much about those details. So come back here, how to use that, how to call that subsystem is you need to declare the 7 segment first. Okay, and after you begin the architecture, you can do something called a port mapping. Okay, you use the 7 segments, you call this keyword. This is the name of this instantiation, and you will say 7 segments, use that. Port map is the keyword, and you put this one is the inputs, this is the outputs. Okay, it's called a positional port map because when you define or you build your 7 segments, you talk this one first and then this one. So this signal will go to this position and this signal will connect it with this part. All right, so you connect the first least significant bits to the input of the 7 segments, and the 7 segment will output something. You connect it to the output port as 7 segment 0 you create here. Okay, you do it 4 times, so this full 7 segments output will be assigned proper numbers. All right, so where this count from, this count is a signal we create is 16 bits, as you can imagine in the, as you have saw in the simple counter. So again, the main code here is +1, right? It's count equals to count +1 if the up down equal to 1, else the count equals to count -1, right? If up down is not a 1, then we just count down, so -1. All right, so where this up down comes from is from the up and down button. Okay, we create another process, we put up and down in the sensitivity list. We begin this process, we say if up equal to 0, then up down is 1. Else, that means up down is 1. Else, if else is 1 and down is 0, then up down equal to 0. Okay, yeah, this is one way to do that. You can define that, but yeah, if I design the circuit, I will only have one switch, right? If a switch equal to 1, then it goes up. If switch equal to 0, then it's count down, right? Because if you have 2 switch, you actually have a 4 combination. We actually only use 2 possibility there. So there are 2 combination kind of like not being used. But anyway, so you can do that, and this definitely work. And you end all those process and entity, and you end your architecture. Okay, so the following is that one. All right, I also write another test bench here, and we can test it to see the result. So this is the counter test bench, and we start a new simulation. We will put those to the region. And I think there's another one we want to see, that is, we want to see the count as well. So I add this one in this window. So let's run the simulation and zoom to full. You can see as the clock ticking, and the up is 0, down is also 0. So in this case, we are counting up. Then you can see the count, you start to count up, right? So if I put this one to a different form, it is a binary number. If we put an unsigned number, it's a decimal number. So you can see we just keep counting to the upwards. Okay. So if I change this one, if I change the up to a 1, then if you can see the code here, if up is 0, then up down is 1. So up down is 1, though we're counting up. So if we else if up is 1, down is 0, then we will count down. Okay. So let's force this one to a 1. Okay. I will force it to a 1. Then I will keep run it for the other part. So you can see it's counting down, counting backwards. Okay. It's counting backwards. So yeah, that's a very quick demo about this code and explanation about this code. Hope you can understand a bit more about this. All right, let me know if I have any question.